For the sake of continuity testing for the cone equation, that is fxy x square plus y square square root. Now, uh, anyway, we saw that it is not partially differentiable at point 0.0 being, I mean, if this is the cone, if this is the cone, then this is 0, 0. At 0, 0, the value is 0, 0, means it is seen that it has no radius, and when it goes up, then x and y in the xy plane, if I see, if this is xy plane, in the xy plane this is 0, 0. When x and y grows, then height also grows. So if x is here, then height is here. So if we see the kind of the uh, the cross section, then or we see kind of when we proceed up the contour, so cross section or contour, when we see, then kind of it is a circle. So everywhere it is a circle, and that's how the equation everywhere everywhere it is a circle. So here it is a point, and then the circle grows like this. So every cross section, the contour, okay, so cross section and contours, okay, all are circle. So equation fxy equal to x square plus y square, that is a square root, that is the equation for the circle. So it holds true means the way radius grows with the x and y, so height is also growing in that fashion. But main thing is that we have to prove that what is the condition of the continuity. We saw that partial derivative is not possible, and then finally error, relative error, exy. So if I have, okay, so if I have a point a comma b and xy is all along the plane, then at any xy that is very near to a comma b, at any xy, if I want to calculate the error means the distance between the tangential surface and the sphere and the graph equation. So if this is the graph, then at any point, so if it is touching this black a comma b, so at that point it is same, but beyond that we can see there is a gap. Okay, so there is a gap. So that gap, so whatever we see the gap, okay, so whatever we are seeing the gap, whatever the seeing, so where it is touching the tangential surface, only one point they are same. Otherwise, between tangential surface and there is a gap. So we can see the gap. Now this gap is the error because they are not the same. So this gap is error. How much this gap is? So if I take any xy around a comma b, if I take any point x comma y, then what is the error? Okay, so I can say error at x comma y, that is the fxy, that is the graph equation of the sphere, that is, oops, okay, so if I like put like this, if this is the point fxy, and down here, down is lxy, okay, this is lxy, xy is a point on xy plane somewhere, this is lxy, this is fxy, then fxy minus lxy, fxy minus lxy is the error. If lxy is the equation of the tangent and fxy is the equation of the sphere, equation of the sphere, cone, whatever, means equation of the model, then error exy equal to fxy minus lxy, relative error that we take through the tangential, through the differential error, that will come at fxy minus lxy divided by x minus a whole square, y minus b whole square. Okay, this is the differential error or relative error, whatever. So if I say that I am xy is nothing but at distance h and k from a comma b. then we are calculating E a plus h b plus k. Instead of x and y, now it is E plus h, a plus h b plus k. At that point, we are calculating f a plus h b plus k minus L a plus h b plus k divided by h square plus k square square. And we saw that it came to, I remember, 1 minus mh, 1 minus, uh, okay, so if we consider that k equal to 0, then it came as m1 minus mh by plus minus h, means absolute value of the h. So to hold this kind of limit to exist where h tends to 0, m has to be 0. But m, that is the dz by dx, is 1 or minus 1. So that is not continuous. We saw that. If something is like 1, then suddenly at 0 it comes to minus 1 and then go like this. So minus 1 plus 1. If that is the way, then certainly it is limit is not happening. So it is not partial derivative, and we also saw that that it is not differentiable. But let's see if it is continuous or not. That the discussion is going on, if it is continuous or not. So fxy equal to x square plus y square square root. Now x is a plus h and y is b plus k. A plus h square plus b plus k square square root. If that is the case, at a b equal to 0 0, it comes to h square plus k square square. Okay, that is, now we are calculating at point 0 dot 0. Now h square plus k square square root. So one fundamental is, if you want to see the continuity, then we'll keep the k as y direction as constant and will vary in x direction. So if this is the x-axis, if this is x-axis, then y, any value y will keep constant and will vary along the x-axis. So we'll keep k as 0. So that will come at h square square root. That will come as plus minus h, okay, or h. So the equation limit is directly proportional to h. This is what we want. So this is continuous. Okay, so looks like Mr. Cone is continuous. There is no problem in the cone, but it is the way the cone is the, okay, why it is not partially derivative and why there is no tangential surface. Now this is the cone, and the question arises is, it is continuous. It is continuous. From here it is coming, so that is h. Okay, so from here it is coming, that is h, and here, okay, if you talk about the continuity, so that is h. H means it is decreasing. If fxy, f a plus h b plus y, or f h k, a plus h b plus k, h f h k, means it is continuous or not against the function we are seeing. So if it is kind of continuous or not, then if we keep k equal to 0, then we are seeing that fxy is directly proportional to h or plus minus h. So as h varies, fxy varies. This is what we want. Means if it is very infinitesimal distance away from the origin, then it is directly proportional to away. Means h is, if h is 0.000001, then its value is 0.00001. So this is what we want. So this is proves that continuity exists. Means the way distance from a comma b grows, the value of the function also grows. So here, if this is the cone, okay, if this is the cone and if this is the cone, and here that is 0 comma 0, here the value is 0, then the way xy grows in this direction, value also smoothly grows, and xy decreases in this direction, value also happens in that fashion. So idea is that kind of if it is a h square square root, then it is kind of absolute value of the h. So it is minus or plus, the fxy is always plus. We can see, right? If it is, okay, so I'll repeat it, fxy equal to x square plus y square square root. Now we are trying to find continuity at any point, that is h, at any point xy. Xy is nothing but at h delta x delta y distance from a comma b. if I consider delta x, delta y as h and k, then we are trying to find the value of fxy at f a plus h b plus k. That will come as a plus h whole square plus b plus k whole square square root. If that is the scenario, if a comma b is 0 0, that is at origin, then it comes as h square plus k square square root. So first we will try along the x-axis where y is constant. So if I k as keep as 0, then it will come as h square square root. That will come as modular as absolute value of h. So whatever h is, either h is positive or h is negative, the fxy is always positive. This is what we are seeing, right? So, so if this is the cone, if this is the cone, then this is 0 comma 0. Here the z value fxy value is anyway 0. But if I come from here, then as the h means x-axis, the h is narrowing down to origin. So the fxy is also narrowing down to origin. This is the behavior. Then if I go left side and h is becoming negative, still it is positive and it is growing in a smooth fashion. So it looks like it is continuous. So we prove that even though it is continuous, if it is continuous, not required that it is partially differentiable. It is continuous, but it is not partially differentiable. And if it is not partially differentiable, then it is not differentiable, that relative error we saw. Now, idea is why partial derivative does not exist. Partial derivative comes into the picture when we go for local linearity. Local linearity means if I want local linearity at certain point, then we will zoom, and then we'll come to a situation when we'll start seeing a flat surface. Okay, so if this is round, this is round. Okay, now zoom. I am seeing exactly flat surface. If it is very near, like if you see moon from Earth, it will look like a sphere. But if you keep zooming, going there, and finally descending there, finally you will land up on a flat surface. But it is not flat, right? Means if you are seeing, someone will say, I have landed on flat surface, it is very flat, I am enjoying running on it. Then someone will say, you are making a fool. Means we are seeing from here it is complete sphere, then how it can be flat? This is local linearity. Means if you go near to it, local to it, then it will look linear. Okay, but this cone, where this cone where it is a 0, the length is the length at 0 comma 0, it is pure narrow. If you go near to it also and try to find the tangential surface, that is a flat surface, near, still very near also it will look like point only, because there is no space there, it is 0. So tangential surface is not possible, because tangential surface means if you go very near to it, it should look like a flat. It will never look like a flat, because there is the kind of if we saw the partial derivative, one side it is plus and one side it is minus. So at this point it is just a point with no width. Okay, there is no width, so the 0. At that condition, if I do the local linearity at that point, it will never look like a flat surface. So tangential surface does not exist at that point. If tangential surface does not exist at that point, means partial derivative, either both do not exist or one of them do not exist. So partial derivative for the cone do not exist. So differentiability do not exist. If differentiability do not exist, partiality do not, still continuity exists. So this is what we saw. Now this is one example where partial derivative do not exist. Now we will go with the another example where partial derivative exists, but continuity do not exist. So certainly differentiability won't. Differentiability requires continuity, partial derivative both to exist. Okay, so that is the concept. So both should exist, partial derivative and differentiability, both should exist. Then I mean partial derivative and continuity, both should exist, then only it will be differentiable at that point. Like fxy equal to xy by x square plus y square. fxy equal to xy divided by bracket x square plus y square. fxy equal to xy divided by x square plus y square. That's it. Now we'll check for the continuity. Okay, earlier we proved continuity is there. Now we'll check for the continuity. Now xy by x square plus y square. Now same we'll calculate at 0, 0 and h and k infinitesimal distance from 0, 0. So f a plus h b plus k, where a and b are 0. Now it will come as h into k divided by h square plus k square. Okay. Now let's consider that h and k are equal. This is also one way. We consider along one direction variation. We will consider if h k are equal. If h and k are equal, so rather than this is x-axis, this is y-axis. This is y-axis, this is x-axis. If I say h and k are same, then somehow we are trying to come from 45 degree. Okay, we are trying. Oops, yeah, we are trying to come from 45 degree. Okay, if I come like this, then it is from x-axis. If I come like this, it is from y-axis. But if I come like this, then it is from 45 degree. If h and k are same. If that is the case, it will come an h square plus a square root h square. So h square, okay, so h xy by x square plus y square. So that will come as h square, okay, that will come as h square divided by, I'm sorry, it is not a square root, h square divided by 2h square. That will come as 1 by 2. Okay, 1 by 2 means fhk at fxy at any xy, it is constant. That is 1 by 2. Boss, we don't want, because we know that so equation is fxy equal to xy divided by x square plus y square. Now we see that at 0, 0 it is 0. Otherwise it is not 0 if it fxy equal to xy divided by x square plus y square. It is 0 when xy is 0. If it is non-zero, not 0, non-zero, if x and y is not 0, 0. Now, when we are seeing the continuity, if you are coming from 45 degree when h and k are same, then it is always 1 by 2. Means if this is xy plane and this is origin, if I come from this side, then it is half and suddenly it will drop to 0. It is not continuous. Okay, means continuity has to be directly proportional to the variable, independent variable. It is constant. This constant means that at okay, at h and k, when it is not 0, 0, okay, xy, if it is not 0, 0, then it's fine, it is 1 by 2. But it is always 1 by 2, independent of any proportional to h or k. So f xy equal to 1 by 2, always 1 by 2. So if I coming from this direction, it is 1 by 2, 1 by 2, 1 by 2. And since at origin it is certainly it is 0, suddenly it drops to 0. Then there is a mountain and it will come like this. Okay, and then again in negative direction if I go, then again it will come up and it will go like this. So it will be like this, and at 0 it will drop like this, then come and then go like this. So like this, drop, come up, then like this. This is not continuous here. So if from origin if I see, then suddenly there is a mountain and then it go like this. Suddenly there is a mountain. So if fxy equal to xy by x square plus y square, where fxy is 0 when xy is 0, it is not 0 when xy is not 0, 0. If that is the case, then we saw that when h and k, we have taken infinitesimal distance delta x, delta y, then delta x is 0 and delta y, when delta x is h and delta y is k, and a comma b is 0, 0, then it is coming, when h and k are same, then fxy is coming as 1 by 2. So in that case, if it is constant or inversely proportional as we have described, and then if Continuity is inversely proportional to the independent variable. Means if independent variable comes near the origin and it grows heavily, or it is constant where it is not matching the value at the origin, it should be directly proportional. So here it is constant where it is 1 by 2. So it is always 1 by 2. So, but at 0, 0, it is 0. So suddenly it comes like this and drops to 0. Then it goes like this and then move in other direction. So at 0, 0, it is not continuous. Okay, it is differentiable or not. So xy by x square plus y square. If I see the differentiability in x direction, that is fx xy, then it will come as hk divided by, okay, so hk divided by h square plus k square. If I keep k equal to, now if I do the differentiability, okay, then it k will always be there, either go for any chain rule or whatever. So if I take k as 0, means y as constant, it will come as 0. Same as fy xy, it will come as 0. So fxy fxxy, understandable, right? Means xy divided by x square plus y square. What is dz by dx? So first it will come as y by x square plus y square. Okay, next it will come as again xy, okay, chain rule, xy into something. So y is both places. Now if I calculating along x direction keeping y constant and y is 0, it will come as 0. Similarly, it will come as 0 in partial derivative along y axis also. So fxy, fxxy, fyxy, dz by dx, dz by dy, both partial derivative are 0. Means they exist. Okay, now it is up to you how you draw the diagram of the xy by x square plus y square. But it is not continuous at 0, but it is differentiable, means rate of change. The tangential surface exists even though it is 0, means flat. If tangential surface is 0, means it is flat. In x direction there is no rate of change. In y direction there is no rate of change. Means tangential surface is flat. If in y direction there is no rate of change but there is direct change in x direction, it will be like this. If there is no change along x axis and there is change along y axis, it will be like this, where there is no change along x axis. It is horizontal, but it is not horizontal along y axis. But it is both 0, means tangential surface is flat at the origin. So it is not continuous, but it is partially derivative is possible. Okay, now now it is up to you. You calculate the differentiability or not. So if we calculate the differentiability, then it will come as hk by, means fxy minus lxy divided by h square plus k square square. So that will come as h, that will come as fx f a plus h comma b f a plus h comma b plus k minus 0, because f a b is 0, and then after that tangential surface is 0, means lxy is f a b plus m x minus a plus n y minus b. So m and n are 0 and f a b anyway 0, it is 0 0 at 0. So right side gone. Now it is h k divided by h square plus k square divided by h square plus k square square. So that will come as h k divided by h square plus k square to the power 3 by 2. That is the error. So if I take k and h equal, that will come as h square. Then down it will come as 2h square to the power 3 by 2. Means the h square, okay, so this proves that denominator is more. H square divided by 2h square to the power 3 by 2. Then it proves clearly, or I mean it will come as directly proportional to h square by h to the power 3, means directly proportional to 1 by h. So the relative error is 1 by h. So relative error varies opposite to h. Means if I suppose the graph, this is not the graph, graph is different, but suppose this is the graph, then the error what we are seeing, the error from here, okay, to tangential surface, the gap what we are seeing, that is the error. That error is inversely proportional to h. So error is inversely proportional, means error proportional to 1 by h. So if I going to near the a comma b, as h is decreasing, error is increasing, where it should decrease, right? The error, when we see the sphere and tangential surface, the error is slowly it is decreasing. At this point it becomes 0, but here error is 1 by h, means it is, as h is becoming 0, limit is happening. When limit is happening, then error is growing infinitely. So differentiability is not possible. Now we saw two cases. One case is that fxy equal to x square plus y square square root. That is the equation. That is the equation for, okay, for a cone. For a cone, when we see the cone, the idea is, when we have the cone, then partial derivative, okay, so partial derivative for the cone do not exist. At this point, partial derivative do not exist. So it looks like tangential surface do not exist. Tangential surface do not exist means if I go near to it, I can never find a flat surface. So, but anywhere if I see, I can see that flat surface. But at this point of the cone, flat surface is not seen. But it is continuous, whatever. If it is continuous and if it is tangential surface exists, that is both partial derivative exist, then only it is differentiable. So it is not differentiable because it is partial derivative is not possible. But we went for another equation, fxy equal to xy divided by x square plus y square, where fxy equal to 0 when xy equal to 0 comma 0, and fxy is not 0 if xy is not 0 comma 0. If that is the case, then we saw that it is not continuous, whereas the both partial derivative, that is 0 comma 0 exist. Okay, at that point 0 comma 0 both partial derivative exist. This proves that tangential surface exists. Okay, we can compute the error, but it is not continuous. In that case, it is not. For differentiability to be, it is not guaranteed also that if it is continuous and both partial derivative exist, then it will be differentiable. Not guaranteed, but it is required that to differentiability to exist, both partial derivative and continuity must exist. On top of it, only differentiability has to be calculated. But if all three exist, both partial derivative and continuity exist, still not guaranteed it will be differentiable. But if 3 out of 3 any one does not exist, then guaranteed that differentiability won't exist. So we saw one case where partial derivative do not exist but continuity is there, so no differentiability. Another case we saw that is not continuous but both partial derivative exist, again it is not differentiable. Okay, now we'll see that both partial derivative exist, continuity exists, but still it is not differentiable. Then we'll see that if both partial derivative are possible and they are continuous, they comes as a function of x and they are continuous, then it is certainly differentiable. So two cases now we will see. So that is the scenario. Means calculus is a science which is impossible to learn if you don't consider step by step. It is the easiest to learn when you consider step by step. So like deep learning we see in artificial intelligence, that things starts from concrete layer and then abstraction layer keep on building up, and at top layer then if we see, then we are made up of the cell and slowly abstraction layer build up and finally you can say that I am a human. But behind the scene every layer depends upon other layer, and the down the line there are cells. Okay, so if you understand things step by step, then you can see that I am a human. But if you don't see things step by step, then probably you will land up in confusion. Okay, that's how the calculus is and that's how the mathematics is. So we'll see now that how great is differentiability and how kind of premier it is, that if it is not continuous, if it even though it is continuous and partial derivative are possible, then still differentiability is may not be possible. So that we'll see.